Hello everybody and welcome back to another video. In this video we're going to be talking about one-sided limits from graphs. And this is KhanAcademy.org, a great website I recommend you use it for yourself. So what is a one-sided limit? Because we've talked about limits, but we haven't really talked about one-sided limits. And one-sided limits are pretty self-explanatory. One-sided limit is a limit from one side. So here, as x approaches -4 from the right, or as x approaches -4 from the left. And another way to say it is as x approaches -4 from values that are greater than -4, and as x approaches negative values, as x approaches -4 from values that are less than -4. And keep this in mind because this is a handy trick that helps me remember. And how would we write this? So it's pretty much basic limit notation. And so if I write the basic limit notation here, sorry for my handwriting. Limit as x approaches, in this case, -4, and as x approaches, in this case, -4, f of x equals what? And f of x equals what? Alright, and so as x approaches negative, some may be asking, why do I have two separate limit notations? And that's where I'm going to explain. So this, remember, as x approaches -4 from the right, it's also, you can say, from values greater than -4. And when you think of values greater than -4, you think of plus. So from the right, or values greater, the limit notation is the same, but just like where the 4 is, where an exponent would be, you just write a plus sign. And as x approaches -4 from values that are less than, or via values that are less than or from the left, you think about just subtraction, or just from the left, lesser, and you just write a minus sign, and that's how it goes, and just pretty simple. So see here, so the question is, okay, the graph of function f is given below. What appears to be the value of lim f of x as x approaches -4 from the right? How do we know it's from the right? Because right here, I don't know if you can see it, but there's a plus sign right there. So that means, like we just said, from values greater than -4, so from the right. And you see here, so x, let's solve the problem. X is approaching -4, -4, from the right, and it looks from here to be stopping at around 1. So if we check, 1 is the answer, and that's correct. For the next problem, the graph of function h is given below. What appears to be the value of the limit of h of x as x approaches -1 from the left? And again, maybe it might be faint on your screen. How do we know that this is from the left? Well, if you see here, it's x approaches -1, and there's a minus sign from the left, from values less than -1. So from the left. And the answers here are 5, -4, -1, or the limit doesn't exist. Another thing, for asymptotes, so you see x is approaching, again, -1 from the left, this side. So what does it look to be approaching? Well, it's not 6, not 7, not 8. It looks to be approaching infinity. But infinity, it's not a real number. So you can't just say the answer is h of x equals infinity, because it doesn't. And so the answer here would be that the limit does not exist, and that's correct. For this one, the graph of function h is given below. What appears to be the value of the limit of h of x as x approaches 4 from the left? Why? Because there's a minus sign right there. Minus from the left. And okay, so we see from the left is going this side. Alright, and the answers here are 3, 4, -4, or the limit does not exist. So just quickly, since this side is the asymptote, if it seems to be approaching infinity, so the limit would not exist. So if this were from the right, the answer would be the limit does not exist. But we're doing it from the left. From the left, we see it's approaching, and it looks to, when it's about to hit 4, it looks to be approaching 3. And so we check that as answer, and that's correct. And for the next problem, the graph of function g is given below. What appears to be the value of the limit of g of x as x approaches 6 from the left? And why? Because there's a negative sign there. So x approaches 6 from the left, what we see goes into asymptote. So it seems to be approaching infinity, but you can't say infinity because it's not a real number. So here the limit would not exist. And if you're trying to do it from the right, as x approaches 6, it would be -3. So if we were trying to find from the right, it would be -3. From the left, it does not exist. And here they're asking for the left. That's the right answer. And that's enough for this video. Thank you guys for watching and see you guys next time.